Today we are going to test and review 868 MHz SAW filter. It is a bandpass filter. Setup includes nano VNA, 868 MHz SAW filter, 2 patch cables with SMA male on each end. To test the filter, we need to calibrate S21 port. Here is my video with the details of how to calibrate S21 port. After calibration, we will test both patch cards by attaching one end to S11 port and the other end of the cable to S21 port. We are looking for 0 dB loss or as close to the 0 dB as possible. Once our cables are tested okay and VN is calibrated, we will go ahead and attach filters with the help of these cables. These cables are 50 ohm cables. In the VNA, I am disabling all other traces and leave only trace 2 or blue color trace. It does not matter which trace I enable or which disable. We can use any of the trace for our purpose, but we need to make sure, number 1, the trace is on channel 1 so that we can observe S21 readings, and number 2, we need to make sure that format of that trace is log MAC. On the VNA, I am skipping details which I already told in my previous videos. I have configured VNA sweep to start at 700 MHz and end at 1000 MHz. This is broad enough to test the range of this filter. Here we can see that the blue trace is on channel 1, which is okay, and we also see that the attached cable has 0.0 dB, almost 0 dB loss. Frequency is 868 MHz. We will check the other cable in the same manner. After attaching the 868 MHz SAW filter, I see this beautiful chart. This clearly shows a peak. This peak should be on the desired frequency, which in this case is 868 MHz. When you move away from the frequencies in either direction, there is a huge loss on the both directions, which is the intended behavior of the SAW filter. I just moved marker on the right side of this peak. Frequency at this point is 883 MHz and we have minus 67 dB loss. From this we can clearly see that this filter presents high degree of rejection for any frequencies above the desired frequency. So any harmonics or undesired products produced in the transmitter will be greatly reduced by this filter. Now I have moved the marker below desired frequency. I can read the current frequency as 844 MHz. At this frequency I can see a rejection of minus 54 dB. So this is quite good, and from the chart I can see that this level of attenuation continues till 700 MHz. This is quite good. Any harmonics or other undesired products will be attenuated greatly and will not cause interference to other services or other operators outside the 868 MHz frequency. So this is the desired outcome of placing this filter. I am happy and satisfied with the performance of this filter. See you again on another video.